back to the channel. In today's quick tutorial, what I'll be showing you is I'll be showing you how to send data from your local computer to your Raspberry Pi Pico in real time. This is an extension of a previous video I did a couple months ago where I showed how to do it vice versa. That is from your Pico to your local computer in real time, programmatically in MicroPython and Python. So if you haven't watched that video, I suggest you do, because there's many concepts in that video that we went over that will be continued in this video, so there may be some confusion if you haven't watched that video. So I'll just link it right here for you guys. And it can also be pretty interesting because if you watch that video and you watch this one, you can essentially create a program where you're sending data back and forth from your local computer to your Pico, and you can do some advanced things if you watch both those videos and you combine the concepts from both of these videos. So enough being said, just a little background. What's going on here in this setup is we have code on our Raspberry Pi Pico, which we're going to go over here in a second on the main.py file. But what we also have is we have code on our local computer. So I just saved a file called local.py. So I'm on my terminal, and this is just an editor for my code, so my Python code on my local computer. So we're running this Python code on my local computer in conjunction with running this code on the Raspberry Pi Pico, so we can send data from our local computer via the serial port to the Pico. And so in this MicroPython code, we'll just go over this first. What we have here is we have a series of imports, and we're just doing this while loop here where we're using this useSelect import to select standard in empty list 0. So this is essentially the most confusing part of this code, and it's not that confusing once we go over what this function essentially does. So how we're sending data from our local computer to our Raspberry Pi Pico is we're just doing it from the standard in. That is, we're just going to send it through the serial port and print to the standard in of that serial port, and our Raspberry Pi Pico will process the data as it's coming in from our local computer. So in this function we have 4 parameters. So we have this first one here. As you could see, I have some brief explanation which we'll go over. So this is just a list of the file objects to monitor for input. In this case, we're just monitoring the standard in. So you can actually monitor other things in more advanced use cases. However, standard in is enough for this use case. Other than that, we have 2 empty lists here. So for these inputs, this is the list of file objects to monitor for output. So we're not monitoring anything for output here, and we're not monitoring anything for exceptional conditions. And finally, this 0 here, this is just the timeout duration in milliseconds. So this is just how long we're waiting for something to populate in the standard in. So in this case, it's set to 0. That means it's non-blocking. So if we do not find anything in the standard in, we're just going to continue. So if there's none, it will immediately return, and we'll continue this while loop, so there'll be no slowing down of our code as we are running. But you can actually play with this value here and make sure, if you increase it, I believe this is in milliseconds, so if you do 1, you can wait for 1 milliseconds to wait for something in the standard in. Okay, so that's all we're doing here. We're not waiting for anything, it's non-blocking. So we're just going to process the data as it comes along. And we have this buffer here. So what's happening is the buffer is initially set to 0, and we're just going to read the select result, so whatever we're getting from the standard in, and we're just going to read character by character here, so standard in.read1. And what we're doing here is we're going to process each character by character in this case, because we're sending a stream of numbers. And so what we're saying is if the character is not equal to comma, this is the new line character, we're going to add a character to this buffer. Otherwise, we're going to save so if we do get a comma, that means we have essentially a new data point. So that's sort of our signal from our local computer that we just received a new data point. So what we're going to do in that case is we're just going to save that buffer to the CSV file here. So we're just calling this save to CSV, and it's just opening a CSV file name. I just named the CSV file data.csv, but really you can name it whatever you want. And we have this A. So A means we're just appending to the file. So if you have an existing file, it's just going to append more data points to that. But you can change this value here based on your needs. You can truncate the whole file and start over. And we're just going to write the data point to the file and write a new line. And then we're just going to reset the buffer as 0. And then finally, we're just going to once again read from the standard in with non-blocking, and we're just going to continue processing forever as long as this thing is plugged into the computer. So that's really all we're doing here on the Raspberry Pi Pico side. So we're getting data, we're processing it one standard input at a time, and if it's equal to a comma, we know we received a new data point. And so we're just going to essentially truncate the buffer, save it to the CSV, and start over until we get more standard in forever, until we plug this thing out of the computer. Now, one thing you'll have to note here is this is on the main.py file. That is really important because we can't run this code in Thani, so I can't just run this code and run the Python code at the same time because they're trying to access the same serial port, and that simply will not work. So the reason it's on the main.py is because this is the file that gets executed when your device is plugged into your computer, regardless of the serial port. So if I go ahead and plug out this Raspberry Pi Pico and plug it back in, this main.py file will start executing immediately. So just one thing to note there. So that's the behavior we want, because we want this to run in conjunction with this script. Otherwise, if we try to run it here in conjunction with the script, we will have issues accessing the same serial port. So that'll all make much more sense in a second. Let's just jump to the code on our local computer here. I hope you guys like this green and black here for the terminal. Some people don't like it, but I prefer it just because it makes things stand out. So we have a very simple script on our terminal. So this is just a Python script, and this is just a Python script in my desktop. So let me just actually exit this first and show you. So for those of you guys who haven't used terminal before on your Mac, it's just a way to access files on your computer and do things with files or other processes with essentially a Unix shell. So I have this local.py file that's located on my MacBook here. And so I'm just going to VI into it, and VI is just a text editor, but really you can edit this file wherever you want. If you're using PyCharm on your local computer or whatever Python editor you have, you can simply do that. So I'm just going to VI into a Python file. So I would imagine you already have Python on your local computer. And so I just VI into that, so this file already exists. And you could just copy the code I have here on your computer. The only thing you'll have to change is the serial port. So keep that in mind. And I just got the serial port from Thani on the bottom right there. On a Windows, it's a little different serial port formats, and I believe on Linux as well, so just keep that in mind. The serial port will be maybe a COM port, I believe, so just keep that in mind. And so in this Python script, essentially what we're doing is we're just connecting to the serial port of our Raspberry Pi Pico, and we're just doing something simple here in terms of our data today. So we're just saying for I in range 1 to 1001, we're just going to print I, so I'm just going to print it on the screen. And what I'm going to do, that's just for debugging purposes. It has no ties to sending data. But where we send data is the serial connection.write. So we're just going to write to that serial port, and that's just going to be a string of this number plus comma. And the reason I added the comma there is just because it's a signal to the Raspberry Pi Pico that this is a new data point. So we want to segment the rows of the numbers that we're getting from this data stream. So I just decided that I'm going to use a comma for that as a signal to my Raspberry Pi Pico that this is a new row of data. And we're just going to encode it, so we have to send it in bytes, so we're just using .encode. And finally, we have this time.sleep 0.01. And the reason this is important here is because if we don't have this time.sleep, what I realized is that the Raspberry Pi Pico has issues processing all of the data. So if we just flood the serial port with a bunch of data as fast as we can, we may have issues in essentially missing some data in the buffer. And so a good way I found to do this is to add a small sleep value while you're sending data over the serial port. And I found that 0.01 works in my case. You may want to play with this value or find other ways to smoothly send data or process all of the data in the buffer in real time. But I think this is a good way, and it's a very small amount of time to wait for processing. Maybe in your case, you want to think of some other ways to deal with that buffer and making sure you process all the buffer. But just know I added this to make sure we process all the data we're sending. And finally, I have this time.sleep before we close the serial connection, because another thing I realized is that if we close the serial connection right away, is that the tail end of the data will get truncated and we won't process all of the data. So keep that in mind as well. So you may want to add a little sleep at the end before you close that serial connection. So we're doing on the Python side, once again, at a high level, is we're just we're just writing these data points to that serial ports, and the Pico is processing all the data and it's going to send it to a CSV file. So in order to get this running, if you watch the first video, what we want to do is simply, first of all, save this Python script. And we can see we're connected in Thani to the Raspberry Pi Pico. But as we mentioned, is we can't run this in Thani at the same time we do on our local computer. So what I want to do is I want to plug this in and out of our, also let me delete this data.csv file because I don't want it to append to that. Let's just delete that. And so I just want to plug my Pico in and out so I don't have a serial connection in Thani, so I can access the serial port in the Python script. So I'm just going to plug it out. As you can see, connection lost, and I'm just going to plug it back in. So now we don't have to do anything in Thani. So the main.py file, as I plug this Pico back in, by the way, I'm not on video today, so you can't see me plug it back in, but the Pico is plugged back in. What's going to happen is this main.py file is executing right now continuously. So it's waiting for some data in the standard in, and there's nothing happening, so it's not writing anything. So what we're going to have to do now is we're going to have to jump back to our Python file here, and we're just going to run this python local.py. So let me just go ahead and run it here. So just give it a few moments there. There is a small sleep, 0.01 seconds, to send all that data over. And if everything happened properly, we should see a data.csv file of 1,000 data points, 1 to 1,000, and we'll be able to see that after this script is done running. So just give that a moment here. Sometimes it does take some time to process there all of the data points. So just a few more seconds here. We're almost at the end. And of course, you could do much more complicated scenarios in this case of data transfer. Now I was just doing a time.sleep for 10 seconds to make sure all of the buffer is processed at the tail end of the data that's being sent over. So now that we have that, what we can go do now is we can actually go back to our Thani IDE, connect to the device, and we will see a data.csv file here. We actually can't open CSV files in Thani, I don't know why. So I'm just going to move it to my local computer. Okay, so I just moved it to my desktop. And let's just open this. And I'm just going to open it in the default app on a Mac. So we can see here that we have all these data points. Let's hopefully we processed the 1,000 properly. So if we scroll all the way down, we can see that we have 1 to 1,000, which is pretty awesome. So I hope you guys enjoyed the video. Once again, I will link all of the sources for the code here in my GitHub page. So I'll link those down in the description below. And once again, this has amazing use cases for data processing on your local computer and on your Pico. So I hope I gave you the tools and everything makes sense for you to start sending data back and forth on your devices. So hopefully you guys can do some more advanced things after watching this in part 1. If you enjoyed this video, I hope you guys subscribe to the channel because there's much more of that to come in future videos. We will be doing some advanced robotics projects and other content such as full stack content if you're interested in that, and Python content as well, and other microcontroller content. So there's much to be seen on this channel. So if you're not a subscriber, please subscribe. I promise you there is a lot of value that you can gain from subscribing to this channel. And that being said, guys, just let me know if you have any questions in the comment section down below. I know we went over a lot, and it can be a little confusing in terms of running the code on your local computer and on your Pico, so please do not be shy and let me know if you have any questions. I will do my best to answer you. Stay tuned, guys. Thanks for watching, and take it easy.